everyone, we're going to do some problems involving inverse properties of logs, and we're also going to do composition of logarithms. So basically, the first thing you need to know is when you see something like this, for example, if you have some base to the log base of x, that's always going to equal x. So when you see something like that, it always equals x, and I'm going to show you why. Look at an example here. If we have 5, let my base be 5. So we have 5 log base 5 of, let's say, 4. I'm telling you, well, automatically you should know that that answer is 4. So let's look and see. Say we didn't know that. So I have log 5 to the log base 5 of 4, and we don't know what that is. So what we're going to do is we're going to use our, b to the p equals x, and the inverse of that is log base of x equals your p. So I'm going to rewrite this as a log. So I'm going to write my base is 5, my number value is x, and I put my power here. Well, my power is this. So we have log base 5 of 4. And in this case, it's very clear that my x has to be 4, because this side has to match that side. So anytime you see something like this, just know that this will equal 4. And then we'll continue on with our problems now. So the first one we're going to have is, these are Math SL questions. We have f of x equals log base 5 of square root of x, where x is positive for the domain, and we have g of x equals log base 5 of x. Now the first thing we want to do is find the inverse of f. So we want to find the inverse of this. And what we're going to do is change this to y. Then switch the x and the y to find the inverse. And then write as an exponent like we did on the previous slide. So I'm going to write my base is 5. So 5 to the x equals square root of y. Or I could say y to the 1/2. Now I'm going to square both sides. So basically I get 5x squared equals y, because this will cancel out here. Now, they want to know what the range of this is. Well, the range of your inverse, so this is your inverse. The range of your inverse is just the domain of your function. So the range is y is greater than 0. Now, the last step we have to do is composition. And what we want to compose is f inverse with g of 4, which is the same as f inverse composed with g of 4. So the first thing I'm going to do is plug in 4 into my g. So that's just going to be log base 5 of 4. So this is your new x, and you're going to plug this into your inverse here. So we're going to write 5 to the log base 5 of 4 squared. And as I did in the previous slide, we know that the answer to this is just 4. So we have 4 squared, that equals 16, and that's your answer. Okay, we're going to do a few more of these, and if you want, you can go ahead and, let's see, I'm trying to find out where I'm at on this one. Okay, so we can do the same thing with a few more. If you want to pause the video and try it on your own, you can. We have log base 6, well, this is f of x, equals log base 6 of cube root of x, where the domain is x is greater than 0, and g of x equals log base 6 of x. First step, we want to find the inverse. And basically, we change this to y. And switch the x and the y. And then use your, set it as exponents. So my base is 6, so 6 to the x equals the cube root, or let's just write this as y to the 1/3 power. And then power it by 3 to get rid of that 1/3. So we have y equals 6x cubed. Now, that's your inverse. And the range is just the domain of your original function. And now we want to find f inverse composed with g of 5. So we plug in 5 in this. So we get f inverse, and this is going to be log base 6 of 5. And then we're going to input this into our x for this. So we have 6 log base 6 of 5 raised to the 3rd power. We know that this equals 5, this part in here. So we have 5 cubed, and that equals 125. Okay. The next one we have is 5 and 3, or 3 and 5. So let's do this one. I have this scribbled down. Log f of x equals log base 3 of the 5th root of x, and g of x equals log base 3 of x. You want to find the inverse. This is also positive. This goes with both of them. So we want to find the inverse, so we switch this to y. Switch the x and the y. And now set it as an exponent, write it as an exponent. 3 to the x equals the 5th root of y. And then we can just power it by 5. So we get 3 to the x raised to the 5th power equals y. And the range is y is greater than 0 because it's just the domain of your original. And now we need to do f composed with g of 2. G of 2, we're just plugging in 2 to this x here. So we get log base 3 of 2. And then we're just going to take this and plug it into my x here. So we have 3 to the log base 3 of 2 raised to the 5th power. Again, this here, that's just 2. So 2 to the 5th power equals 32. All right. And I have one with 11 in it. Let's do that one because that one looks scary. We have log base 11 of the cube root of x is your f of x, where x must be positive, and g of x equals log base 11 of x. First thing we want to do is find the inverse. So y equals log base 11 of cube root of x. Switch the x and the y. And use your, write it as an exponent. 11 to the x equals the cube root of y, or 11 to the x equals y to the 1/3. Now power it up by 3 to get rid of this 1/3. So y, which is our inverse, equals 11 to the x cubed. Now, the range is just going to be y is positive, because it's just the domain of that. And what we want to do is find f inverse composed with g of 2. Well, g of 2 is simply log base 11 of 2. And now all we're going to do is plug this in to our x here. So we get 11 to the log base 11 of 2 cubed. Again, we know that this here evaluates as 2, so we get 2 cubed equals 8. I have one more. The last one is log base, this is f of x, of 7 to the 4th root of x, and log base 7, well, g of x equals log base 7 of x. Again, x must be positive. So, and this is a 7. Okay, so we're doing the same thing. We're going to find the inverse, so we switch this to y. Switch the x and the y. Write this as an exponent. Power it up by 4 to solve for y. So you get 7x raised to the 4th power is y. And our range is y must be positive. And the last step is we're going to evaluate and compose f inverse composed with g of 3. Okay, so we have f inverse composed with g of 3. G of 3 is just going to be log base 7 of 3. I'm going to plug this into our x here. So we get we get 7 to log base 7 of 3 to the 4th. And this we know, this equals 3. We have 3 to the 4th equals 81. Okay. Thank you. Have a nice day. Bye-bye.